Today's video is going to be about reviewing SEDCAD calculations. Before I get started on that, I think every plan reviewer should have a copy of the SEDCAD user manual. It's online, not that easy to find, but I'll show you real quickly how you can download that. Okay, my zoom here is a little messed up, but if you go to Google and you type in SEDCAD user manual, it should be the fourth link that pops up, this pdfslide.net website. When you go to that website, there's an option to download the SEDCAD user manual. So that's how you can find the copy of the SEDCAD user manual. Okay, so the first thing that I like to review in SEDCAD is the correct soil types are used. So navigate to your soils map, and you can determine, which is the predominant soil type. And there's a, decision you have to make here. Typically, sites will have multiple soil types, and you'll have to decide: do I want to use the soil type that's most common, or do I want to use the worst case scenario? Sometimes down in the bottom of the site, in the low-lying areas, there'll be soils with high silt contents that are not necessarily representative of the entire site or representative of the soil that will be used on the site. So typically I go with the predominant soil type. Cecil is the most common in the upstate where I am from, and you'll see that the engineer can put in here the percent passing the different sieve sizes. So this document is a part of SCDHEC's Stormwater BMP manual. I believe it's Appendix K, and has the soil type for all the soils in this geographic area. So for this site we're looking at today, they use a Cecil soil. That's this one. And you'll notice there's different depths. So this number on the far left, 0 to 7, is the inches. Going down in the soil profile, and then 7 to 11 and 11 to 50, and those ranges vary for each soil type. But you have to make a decision on which one is most representative of the site. And again, you can do the worst case scenario, or you can do what makes the most practical sense. So for this soil type, obviously they typically remove the topsoil first, and some areas may be 2 feet of cut, some areas may be 10 foot of cut, but for Cecil, the one that is most representative of a typical construction project is this bottom soil type, or bottom profile. And it's also worth noting, the larger numbers toward the end are the worst case scenario, the soils with the smaller fines and that are harder to increase your trapping efficiency. So you'll want to make sure these numbers here match the numbers that are used in SEDCAD for the individual sieve size. So this number up top, this has particle sizes with the different numbers. This is the sieve, the openings in the sieve diameter, and then it gives you the percent passing. So now going back to SEDCAD, these numbers should match what's in that appendix for soils. And there's a lot of different references for those rotable particle size distributions. The most common in South Carolina is the DHEC BMP manual, though. Okay, so the next thing I typically review in SEDCAD is that the hydrology inputs are correct. Check areas. I was actually on the wrong table there, corrected it. So check the areas match up in your watershed maps, and of course there should be a during construction watershed map that correlates to the SEDCAD calculations for each watershed. Then you also want to check that your curve number is correct. In South Carolina, DHEC gives you the curve numbers for the different hydraulic soil groups. So this is for a hydraulic soil group of B is 86. One thing I want to note in this, if there's multiple watersheds going to the pond, and some are stabilized and they're not disturbed, you can use a different curve number there, and that's okay. But what they can't do is assume a lower curve number. I don't have an example here. I'm just going off the wing here. But if there's a watershed with a lower curve number, this C factor that you see right here, it should not be 1. That C factor, what that represents is that the entire site is disturbed. There's no cover. So what that does is generates a lot of sediment into the model, and dirty water is easier to clean than clean water, if that makes sense. So when you have a lot of sediment go into the pond, it's easier to drive up your trapping efficiency. So again, to summarize, if you have multiple watersheds, and some of them are stabilized, if they want to use a curve number of 86, then I let them assume, or a curve number that is totally disturbed, then I let them assume the C factor can be 1. But I do not allow them to assume a lower curve number because it's stabilized or partly stabilized, and then use a C factor of 1. They have to use an appropriate C factor. If that watershed's 50% disturbed, it should be 0.5. You'll also want to check this soil K factor that I'm circling here. And the K factor will be in the soil tables we were looking at earlier. This is an erodibility of the soil. So if this is incorrect, it can definitely change your trapping efficiency results drastically. Going back to the soil tables, here is your K factor that I'm circling with the cursor. Okay, so the next thing I like to review after checking out the watershed information is I want to make sure when sediment basins are used that the correct information is put into the model. So you'll want to check that your spillway elevation is correct. That's the top of the riser, the crest length of the riser, the riser diameter, of course, is an important one, and riser height is another important one. Barrel slope, barrel diameter. Check all these that they correlate, and there should be a detail in the plans of the pond, and you'll want to make sure that all these inputs for the spillway correlate to that riser detail. Okay, now what I'm circling here that says drop inlet, so that's the riser, and that's the one you most commonly see. I have seen engineers that like to use the enhanced perforated riser, and I don't know why they do that. Perforated risers aren't allowed in South Carolina anymore with the surface withdrawal requirements. So what they do is, essentially say there's no holes in the perforated riser, but then they still model it that way, and it does change the results a little bit. I don't know the background behind the model. I don't know if this drop inlet maybe uses different weir factors and weir coefficients. Those perforated risers were typically CMP, where a drop inlet, is more commonly a concrete riser. So there could be some differences there. I've in the past have allowed both. I've questioned why those engineers will do that and haven't gotten a great answer, but when I did ask them to run it the other way, the calculations will change a little bit. So that's something to watch out. The drop inlet type riser is the one that's most commonly used to model a concrete riser, though. Another thing to note that I skipped over, I'm circling here now, is dead space, and it's set at 0% for this project, and I'm okay with that. So dead space is essentially areas in the pond that are not used, where stormwater essentially short circuits. The theory behind it is there's eddy currents inside the pool, and certain parts are inside the pond, and certain parts of the pond are not completely mixed. Now, porous baffles are supposed to help eliminate the dead space issue. So now that our construction general permit typically requires porous baffles, and that's supposed to kill the dead space, it's okay with having that at 0%. You will still see some projects that use 20% dead space, and that was kind of a common number that was used prior to porous baffles. But that's a decision you'll have to make if you allow dead space to go all the way down to 0. So lower dead space, higher trapping efficiency. higher dead space, lower trapping efficiency. For the purposes of this video, I'm not going to go over reviewing skimmer calculations. They're pretty straightforward to me. But once the engineer does size the skimmer, and it should be in the SWIP, and it will have a flow rate, you just check that the appropriate flow rate is used. And the engineers model this by coming in and putting in a user-defined discharge, the one I'm circling here, and then it's a constant flow rate through all depths of the pond. And you'll just want to make sure that stays constant throughout the depth to accurately model the skimmer. And this was in the detailed discharge table in SEDCAD. Okay, so the next thing I like to review is the freeboard requirements and peak discharges from the pond. SEDCAD usually throws in the peak stage here, and then you can go over and look at the peak discharge. And this was modeled for the 10-year storm, so there was 83 CFS for the 10-year storm. And technically, during construction, peak discharges should be below pre-development peak discharges. So if you'll want to confirm that the pre-development peak discharge is less, is equal to or greater than what it is during construction. And then you'll also want to see what stage in the pond. So for this one, for instance, it would be 811.97. And you would want to make sure that elevation is at least 1/2 of a foot below the invert of the emergency spillway, so you have appropriate freeboard during construction. Another thing that you can review is how high the water gets below the top of the spillway. So for this one, the top of the spillway is at 811, and the peak stage is 811.97, so it got approximately 1 foot above the top of the riser for the 10-year storm. And you have to make a decision. If it gets 2 or 3 foot above the top of the riser, is that still considered surface withdrawal? And that's actually kind of a complicated answer that I'm not going to go into. It depends on if the flow control is still in weir flow, or if it has transitioned to orifice or barrel flow control, which is a little bit more complicated to get into. I believe DHEC has, and certain municipalities has set certain maximum depths above the riser that the 10-year storm can get during construction. 1 foot's a good number, but if it's a large riser, it could still be in weir flow control even with 2 or 3 foot of head above the top of the riser. And then, of course, the final thing, the most important thing, especially in South Carolina, we have a 80% sediment trapping standard during construction, is you'll want to look at the pond results, and down the very last one is a trapping efficiency. So for this one, it was 75.06, so that did not meet the 80% standard. Then, of course, you'll also want to note the dewatering time. In South Carolina, it should be 48 to 72 hours. So it puts it in days, but obviously you can convert that over to hours very easily to make sure the pond is dewatering quickly enough. I believe that's it for this video. If you have any questions or comments, please feel free to send me an email or a phone call. Thanks.